Okay, so this is part four. We may have five parts here. So this is a slide of global water use. And 70% is used for agriculture, primarily to irrigate crops, 19% used for industry, and 11% for municipal and domestic uses. Um, so the share of water for agricultural uses can be as high as 95% or as low as 0.3% in 95% in Vietnam and 0.3% in Germany. I I would imagine it's very high in Hawaii for agriculture. I'm not quite sure of the exact number there for water use. That may be a discussion question I have for you to find out what the Hawaii water use disposition is. I know in California it's very high for agriculture, and California's had a number of water battles through the years between agricultural interests and urban interests. Now here we have a model of surface water allocation between agriculture and industry. Um, it's a two use graph, and and so while there's enough surface water, getting it to the right places is quite the problem. And a huge issue is water rights. Who has the right to the water? And that's oftentimes a legal and or political issue. Now, if water was priced correctly, which it isn't, efficient allocation would happen. And what does efficient allocation means? Well, the graph to the right shows that efficient allocation would occur until the marginal value of agriculture um, equals the marginal value of industry. Um, so the efficient division occurs when a marginal value is equal for agriculture and industry. At any other allocation, the movement of one unit of water from that sector will lower the marginal value to the unit to the other sector with a higher marginal value, would yield a net gain. So, water gets traded back and forth between industry and agriculture until the marginal values are equal. And this is kind of similar to what we call intertemporal substitution. As we substitute away from one good to the other, we substitute until the marginal utilities are equal for the two goods. So here we have a optimal price here. Now your book talks about Taiwan and the drought story. So Taiwan had had a rather massive drought, and and what happened was there was no free market for water. There was no real pricing structure, good pricing structure for water. So non-price rationing was a consideration in Taiwan. The government took 34,580 acres of rice paddies out of production and set aside sufficient water supply for household use and reallocated the remainder to industry. So this was not done on the basis of trading back and forth. This was done by, in essence, government decree. Um, this was not the efficient division of water. This was done because this was not done based upon marginal valuation of the individuals. This was done strictly by government. And here we have a picture of a method of water, shall we say, allocation is the storage of water via dams, and then this water gets allocated to different uses. This is very common, maybe not necessarily in Hawaii, but very common in California, in Arizona, Oregon, and the like. Very much the case in western states. Now, water rights. Now, who has the water rights depends upon the type of law being used. Riparian laws are used in the United States, and riparian laws are protect the water use rights of landowners on riverbanks and lake shores. They're generally retained regardless of whether the landowners make use of the water. So I guess if you own land near lakes and riverbanks, you have access to the water. Um, and riparian water use is limited to reasonable beneficial use. The water cannot be diverted for use elsewhere and cannot be stored for later use. Oh, interesting. When water supplies are inadequate for the demands of riparian users, it is typical for household use to take priority over commercial use, and for riparian use to take precedence over use by appropriators as described next. Prior appropriation laws are oftentimes used in the western United States. These grant rights to those who first use the resource, provided they are still using it. So first in time, first in right. And whoever gets to the water first has access to the water. Very, very interesting. Now, does either law incentivize efficient use of the water? And according to your book, answer is no. They have an example of San Bernardino. With prior appropriation rights and negligible marginal costs, the farmers in San Bernardino County will use water until the marginal value of agriculture meets the horizontal axis, exceeding the efficient division between agriculture and industry. At that point, the marginal value of agriculture is zero, and the marginal value of industry is positive. So there could be some efficient reallocation of water, but it doesn't happen because of these laws. They have access to the water, and therefore they use it. Now, we've got different water pricing structures, and I'll just go over that. I think I may. Yeah, I'll just go over this. I may do one more section. So first of all, we have something called flat rate and flat fee. And a flat rate is a fixed amount paid per unit of water used. A flat fee is a fixed amount paid per period, regardless of water use. Decreasing block is a per unit price that decreases as water use increases. And increasing block is a per unit price that increases with water use. Average cost is a flat rate equal to the average cost of providing water. Peak load, the price increases at times of shortage. And finally, marginal cost, the price reflects the marginal cost of providing water. Now, your book has some examples. In Reno, Nevada, they pay a flat monthly fee of $49.19 for water serviced by limited by the 3/4 inch connection. In Delaware, consumers pay a flat fee of $10 a month. These flat fees do not encourage efficient use because the marginal cost of water to the consumer is zero. Your author has a great little quote here. Paying a flat fee for water is like going to an all-you-can-eat restaurant. There is no incentive to stop consuming until the marginal benefit of another unit is zero. So we're not even looking at marginal cost. We're just looking strictly at, can I consume more water? And up to that point where it's zero, my extra benefit, I'm just going to keep on doing it. Now here is a visual of pricing structures. My apologies for the vertical axis for uniform rate. So here we have a uniform rate, which is a flat rate. Increasing block, which is going up as the quantity of water is used, and decreasing block, the price is going down. We economists would argue for an increasing block, which would be more efficient and cover the rising marginal cost of obtaining that water, and would be more efficient and allocate the water much more efficiently. Uniform block rates do not create any incentives for conservation, and decreasing block rates encourage greater consumption. Increasing block rates encourage economic actors to internalize the need for more efficient water practices. Okay, so that is on the visual for pricing structures. What do we got? Let's do. I'll do one more section here. So we'll end it right here for this fourth section.